Hello guys, welcome back to class. In this session, we'll continue the module 4, distributed systems. So in the previous session, we have seen up to introduction to distributed systems, fallacies, key challenges, communication, types of failures, CAP theorem, Pace-LC theorem completed, right? So those topics are given in the part 2 of the notes. This has started with the part 1. Now this is a part 2 because the length is increasing. So I made this. So in this, we'll see the consistency models and quorums, distributed transactions more deeper, and then distributed system patterns. These topics we'll see in this. So let's start with consistency models. So now, previously we have seen somewhere about the consistency models. If you remember any names, only names, if you remember, just tell me what are the consistency models we have seen in the previous topics anywhere till now in the system design course. Have you remembered any consistency model names we discussed till now in the system design course? Chandra, very good. Eventual consistency. That is the one we used heavily, I think we discussed more. Strong consistency. Weak consistency. Eventual consistency is the weak or weakest consistency. Okay. So previously we used only two cases. Let's now explore more. So what is a consistency model? We will define how operations appear to execute in terms of time and visibility across different replicas. Now we are talking about distributed systems. What's the meaning of distributed systems? Maybe your application distributed across multiple nodes, or your data is placed at different nodes. Consider a data. Your data is placed in a different nodes. So what are the techniques you use to place your data in different nodes, different computers, different nodes? What are the techniques used to place the data in different nodes? What are the techniques used to distribute the data across multiple nodes? At least by seeing this term, you can understand a replicas, replication mechanism, right? Replication mechanism. You have a data, you want to keep multiple copies of the data across multiple machines. Yeah, maybe, yes, the two ways, partitioning, and remember this. Our distributed story comes around these two topics only, guys. Already we discussed this. We have seen about a partitioning, right? In partitioning, we have a vertical and horizontal, but mostly we use the horizontal partitioning called shards. Second is replication. So these two are the main techniques where we keep the data. In the case of partitioning, say we have a node 1, node 2, and node 3. So what we do in the partitioning? Suppose I have a 30,000 customers. I'll keep 10,000 customers here, 10,000 customers here, 10,000 customers here. Maybe range-based partitioning I am doing. Okay, maybe 10,000, 30,000, I may not keep in a single node. So I'm partitioning into three partitions based on some partition key. So keeping in 3. So total data 30K, I am partitioning into 3 nodes. There's a partitioning, horizontal partitioning, sorry. What's the replication? So I have a data in node 1. Maybe consider as 30,000 only. my node is enough to store, it has enough space to store the 30,000 data. Yes, I stored. But for the fault tolerance, what I can do replication, right? Node 2 and node 3. This 30,000 data, again I am keeping one more copy. 30,000 data, again I am keeping one more copy. Is this the replication, guys? So this is my first copy, second copy, third copy. This copy only we are calling as a replica, right? Replica 1. This is another replica, this is another replica. So 3 copies, 3 replicas I have. And this is not a replica, right? This is a part 1 or a partition 1, part 1, part 2, part 3. So this discussion will talk about this, the transactions. When you're talking about transactions, we'll talk about this partitioning much. Currently take the replication. Okay. Now you have 30,000 customer data in a 3 copies. Now, if any customer data changed, suppose customer email ID changed, simple case. Now, is it required to update all other nodes or not? Is it required to update all other nodes or not? All 3 copies, right? You have to update all 3 copies. You have to update all 3 copies. When you want to update, do you want to update immediately? Do you want to update slowly later? Do you want to update immediately or do you want to update slowly later? Depending on the use case. Am I right? Depending on the use case. This consistency models deals with the same. Consistency models deals with the same. See how operations appear to execute, your operations appear to execute in terms of time and visibility across the nodes, across different nodes or different replicas. So whatever operations you do, how these operations will execute? Time, immediately or slowly? Visible to all means immediate, visible slowly, right? The consistency models deals with this, how operations will execute in terms of time and visibility across different replicas. So we have 4 consistency models. First is the linearizability. Second, sequential consistency, causal consistency, and eventual consistency. There are some more small are there, but I think these 4 are the most important. And nowadays, you consider any real world application, you're going to see only these 4. Fine. So in this, the first one, linearizability, is the strongest consistency model. Is the strongest consistency model, and eventual is the weakest model. The strictness will reduce like this. Linearizability is the first strongest. Second strongest is, sequential is lesser than linearizability, but better than causal. Causal is still weaker than sequential. Eventual is the weakest. There is the scopes or how they provide the strictness. Strictness decreasing. Okay, let's understand each of this and where to use in the real world applications. First, we'll understand each one by one. Then we'll go for the real world use cases. Let's start with linearizability. So linearizability is also known as strict consistency. It is called as strict consistency, and we can call this as strongest consistency model. See, there is no consistency model called strongest consistency model. This linearizability is the strongest. Okay. It is also called as strict consistency model. It is also called as strict consistency model. Fine, linearizability. So if you see the strictness and strongest means, I think by reading this line you can understand. See, linearizability ensures that all read-write operations appear to happen instantly and in the real-time order. Instantly and in the real-time order. Means each operation you do, it happens immediately. Immediately. And in the real-time order. This term you remember why I am calling real-time order. When we are talking others also will make a difference. Why some consistency models are maintaining the real-time order. Some consistency models will not respect the real-time order. So how it is will make the differences. Okay. So suppose client A is writing a data x equals to 10. Operation is success. When client B is reading x, it must return 10. When a client C is reading x, it must return 10 only. So it happens after A writes complete. Means once A completed, if you are doing this, B is reading the x, C is reading the x, or somebody is reading the x, then it has to return the updated value. When you apply linearizability consistency model, when you apply linearizability, then it gives you the always updated values. The operations will happen instantly and guarantee the real-time order. It means you will get instant values. Now you can ask a question whether it is getting a data from one node or multiple nodes. Suppose I'll ask you the question, I have node N1, node 1, node 2, and node 3. Okay. So here current value maybe initially x is a 5 guys. Make x equals to 5, x equals to 5. So client A is writing x10. Client A is writing write x equals to 10. So maybe writing to node 1. Client will write to node 1 or all the nodes. Client will write to one node or all the nodes. One node, very good. So here this is changed x equals to 10. Now client B is reading here. Client B is reading here. What is x value? When a client B is reading is here, B is reading x. What is x value? But what I am telling, maybe here it is currently 5. But if you see, B, when a B reads the x, it has to give the 10 only. When a C reading x, maybe C is reading other node. Suppose C is reading the node 2. C also has to get 10 only. B also has to get 10 only. When it is possible, very good. Means the right operation happened should be updated with all the replicas immediately. So when you do right, this is updating immediately here also. Immediately here also. So that later anyone is reading, they'll get x value 10 only. So linearizability guarantees the latest values always. That's what we're calling it as the strongest consistency. Banking applications you take. Banking applications you take. So we need accurate values, right? Banking applications, financial systems. Do you entertain the stale data? No, right? In a critical systems like a banking, financial systems, we won't entertain the stale data. We want accurate data. Means the writes happen to one node should be replicated to all other nodes immediately. If you want that, you have to apply the consistency model called linearizability. Is this clear? Linearizability is clear, guys? Yes, Anik. Yes. Always consistency and availability. There is a trade-off. That's we are coming through the cap theorem, right? We are coming through the cap theorem. So after the cap theorem, we are studying this. When you have C and A, you will get only one in that. Right? That's the cap theorem. You cannot get C and A. When you get a strict consistency, when you apply the linearizability, this is happening immediately. What about availability in this? So definitely how to compromise availability, right? These systems are, if the strong systems implemented based on strong consistency will have less available, or performance wise also less, right? Performance wise, availability wise, these systems are not okay. Clear? Okay. Let's see the other points about linearizability. What are the key properties we understand about linearizability? Remember that linearizability respects the real-time order. Respects the real-time order. It means immediately it happens. So once a write is done, this is what we observed from the previous explanation. Once the write is done, all subsequent reads must reflect that updated, the latest value. Must reflect that. That is what immediately reflecting, right? That is the linearizability. So where I can use ideal use cases in a banking, financial systems, inventory, stock management, order processing in e-commerce, distributed payment gateways, wallets, lock managers, like in a Zookeeper lock managers, we can use this. Critical, immediate, you can go for this. So is this clear, guys? Linearizability is clear? Any doubts on this? Can I move? Can I go to the next one? Okay, next one. Sequential consistency. Sequential consistency. Sequential is little bit weaker than linearizability, means not that much strict. Sequential consistency is weaker than linearizability. Okay. So this is important point you read. Operations from all the clients are executed in some sequential order, but not necessarily in the real-time order. Operations from all the clients are executed in some sequential order, but not necessarily in the same order. I'll explore that with an example, understand. So at least the sentence you got into mind, that is enough. Second important point, respects the sequence of operations used by each individual client. These 2 points, to explain these 2 points, I have taken 2 examples, scenario 1, scenario 2. So first see this point, guys. Operations from all the clients are executed in some sequential order, but not necessarily in the real-time order. Okay, let's start the scenario 1. Client A is doing write operation, write x equals to 10. Okay, client A is doing one write operation. After that, client B is doing another write operation where x equals to 20. Now tell me, when I read, client C is reading x. Client C is reading x. You tell me, guys, what will be the value of x now? Only Ashwant answered. Chandra also told 20. Maybe right. That is sequential. If you do same thing in the linearizability, linearizability respects the real-time order. What is the real-time order? First you are writing x10. So x value becomes 10. Then you are writing x equals to 20. Then definitely x changes to 20. Later, when anybody reading X value, it has to give 20 only. That guarantee is there in the linearizability because it is respecting the real-time order of the operations. What is the real-time order? Wall clock order. Wall clock order means real-time order or wall clock. Real-time is based on time. For example, you have done, I'm currently taking a single node only. Let I have X equals to 5. Now, client A is doing one write with X equals to 10. Maybe client is doing this at a 6 o'clock, 6 hours, 35 minutes, 10 seconds. And B is again doing a X equals to 20. It was the 6 hours, 35 minutes, 27 seconds. So as per the real-time order means, this is the first operation. As per a wall clock time, this is the first operation. What's the real-time order, guys? Write X first, write X equals to 10 first, write X equals 20 is the real-time order is write of 10, then you have write of 20, then you have read of X. It has to give 20 when it is following a real-time order, yes. But sequential consistency, sequential consistency. Now see guys, that's the Girish I'm telling. See, if you follow the linearizability, which is guaranteeing the real-time order, then your read X value always 20. Is this clear? Now, when you come to sequential, it does not respect the real-time order. It may happen, may not happen. But all the operations happen in a sequence, but may not be in the real-time order. It means there are two possibilities here. There are two possibilities here. See this. It may consider first write of 10, then write of 20, and maybe write of X, the read of X. Now 20 may come. If the write of 20 happening first, then 10 happening first, 20 happening next, then 20 takes. The order can be like this also, guys. 20 happening, then write of 10 happening, then when you read it, you may get a 10 value also. All the client operations will run in some sequential order, some sequential. It may be first X equals to 10, then X equals to 20, or X equals to 20, then X equals to 10. Either this order or this order, anything can happen. In this case, X equals to 20. In this case, X equals to 10. So, is this a real-time order? In this, what is the real-time order? Real-time order is this. But if it is not going for a real-time order, then you may get X value also. So, sequential, your operations happens in a sequence, but not necessarily it may happen in the real-time order, may not. So, read of X could return either 10 or 20. Read X can return either 10 or 20. But if C is getting, for example, 10, even though 20, if C is getting 10 only, all the clients must agree on the same sequence, right, of 10, then 20, read X. So, if C sees the X equals to 10 before X equals to 20, every other client must see the same order, even if X20 was actually written later in the real-time order. This point is very important. All clients must agree on the same sequence. For example, this is client C. client D, client E. Client E is reading X. Client D is reading X. Client C is reading X. If the order is happening here as you are writing in a 10, X10, X20. But as of now, X value is 10 only. It means X10 updated. Still X20 issued, but not executed as of now. Not executed. So if X is X10 confirmed, even though it is updating this letter, all clients has to read X10 only until this operation done. Means in the sequential, you tell me one point. In the sequential, any chance for getting a stale data? Sequential, any chance to get a stale data, guys? Any chance to get inconsistent data, stale data, outdated data, or old data? You have a chance because actual X is 20, guys. Still that is not updated. Currently on the diagram on the screen, I am showing you the single node. You may have a n number of replicas. N number of replicas. Even, I mean, what is the point is, let me take the replica mechanism. See how it works. This is my node N1, node 1, where X equals to 5. My node 2, where X equals to 5. Node 3, where X equals to 5. So here I am doing, A is doing write of X equals to 10. And this is changed to 10. Then B is other hand is doing X equals to 20. When X equals to 10, it has to be replicated, right? So assume this replication is done here. This replication is done here. X20 changed here. Still replication is going on. By the time, say, the B is reading X, this will get a 10 only. Now, even suppose by the time the 20 replication happened here, it won't take the 20 because the 10 is agreed by this client. X value 10 this client is giving. So all clients has to read on the same value. 10 only everybody will get. Until the 20 is fully replicated. Until the 20 is fully replicated across all the nodes, 10. Once 20 is replicated all the nodes, then you have a 20 for everybody. So in between we have gap. So there is a chance to get a tail value, right? Stale data. I am getting a 10 stale data. Actually, the 20 is updated here, but not replicated. By the time I am getting 10, even though 20 updated, it will give the 10. Read X 10 only, guys. Remember this. Read X, it will give 10 only. Because still this is not replicated. Once all are replicated, now if a client is reading, this will get 20. Now it will get 20. Everybody will give it 20. Okay. So if C sees the X10 before 20, remember, see this point. So if C sees X equals to 10 before 20, then every other client must see the same order, even if X20 was actually written later in the real time. It is writing later, maybe it is coming up, even though if whenever client C is seeing the first X equals to 10, every other client has to see the same order. So all the clients, operations from all the clients are executed in some sequential order, but not necessarily in the real-time order. Just there is a small real-time order, not guaranteed on this. So In between, we have a chance. There is a chance. We can't guarantee that always tail data. We can't guarantee always tail data. Because if you see this, read X could return either 10 or 20, depending on the gap time. If you are getting 10 means maybe it is tail data. So there is a chance to get a tail data. And second point you read, respect the sequence of operations issued by individual client, each client. If one client is doing multiple operations, it respects the order of operations given by one client. What is the meaning of that? Elaborate. Okay, I have one more use case. Come back here. Scenario 2. Suppose client A is writing X10, X20. Client A is done two operations, X10, X20. Client B is writing X99. Now, client can see any global sequence, something like this. So, here I shown some orders as valid, some orders as invalid. You see these orders, tell me why invalid. Tell me why invalid. And read this line. Read this line. Read this line. Respect the sequence of operations issued by each individual client. Respect the sequence of operations issued by each individual client. Respect the sequence of operations issued by each individual client. Come back to this. Now tell me, what do you understand from this? Okay, come back. The replication, whatever replication mechanism you take common, your replication mechanism is immaterial for us. See, generally, what is the real-time industry standards now you take? I think some of you have done my AWS classes, right? So in AWS, what is the main database replicas you studied? Primary replicas. You may have a primary one where the write operations happen. Maybe replicas are the n number which will help you for a read operations. Replicas mostly for read operations. Okay, right. So come back to this point. So the point answer is, Aman, you take any replication architecture that is immaterial, any infrastructure you take, any cloud infrastructure you take, any replication mechanism you take, your communication, I think Anek asked how it is communicating. That is all depending on your network. There is a replication architecture you follow. Whatever you follow, same scenario happens. Okay, I think here you may get some more clarity. Again, I am asking you. Okay, let this go. A is writing X10. Okay. B is writing X equals to 99. So here is X value, which is the 5. Here is X value, which is the 5. Here is X value, which is the 5. So A and B. So tell me now, which one happens first? In a wall clock order, you are doing the first this only. First A has issued one write operation where X equals to 10. Next B is issued another write operation where X equals to 99. Which will be updated first? To the my last replica. To to my last replica. Shashi, that's what the point here. That's what the point, Shashi, Aman, Mahesh. Right? Okay. So in this, how these operations will happen? In some sequence, it may replicate 10 first, it may be 99 first. Am I right? If the real-time order is guaranteed, first 10 only will be replicated to all, then 99 only will be replicated to all. That is the real-time guarantee. But in any sequence means, so first maybe 10 can be replicated to all, and then 99 will be replicated, or 99 will be replicated first to all the nodes, and then 10 also can be replicated. Replication will happen, guarantee, but may not be a real-time order. What is the meaning of that? It may replicate 10 first, it may replicate 99 first. Okay? But so what is the order now? Either 10 or 99. But A is doing another operation, x equals to 20. X equals to 20. Sashi, I think last right may not win always. That's what there is a small difference. Let me to complete. I think you will get a clarity. See, A is doing two operations, and B is done one operation. Now, A is a one client doing some operations. B is a one client doing another operation. For these two operations of A and B, there is no order guarantee. Some global order. It may be A first or B first. But A is a multiple operations, it respects the order. It means, what is the possible cases, guys? Write x10, then write x20, then maybe write x99. This may be order of these operations, am I right? Is this one valid order? Tell me another order. Write of x equals to 99 means write of x10, write of x equals to 20. This is also valid, right? See your maintained, client operation sequence maintained. One more valid case is there. Very good, Girish. Write of x10 first, then write of x99, x20. Sequential order is maintained as with respect to one client. For a one client, sequential order is maintained always. See, if you take A, client A has done two operations, x20, x10, y20. That is always maintained, see. 10-20 in the same order, 10-20 in the same order, first 10, then 20, same order. But this is impossible. x20 first, then W of x10, then maybe x99. This is not possible. So do you understand this? Operations by different clients. A sum operations, B sum operations. So now it will do the sequential order, some sequential order, maybe A first or B second. See this, first A first, then B. And this is first B, then A. This is the global order. But one client related, A related operations happening sequentially. Point is clear, guys? Everybody? Now you tell me the real world example. Some real world. Okay, let me to revise these points, then you tell me the real world. Here you see, guys. Why the last is invalid? Tell me. Why this is invalid? X20. Client A operations must happen always 10 first, second, 20. But this is not happening. This also client A operations. AB operations can happen in any order, but one client operations must be in the same order. Okay, this is the guarantee what this consistency is giving. Fine, come back to read this point. See, it respects the sequence of operations issued by each client. This point is clear. Respects the sequence of operations issued by same client. Okay, that is A2 operation sequence always maintained. Operations from all clients are executed in some sequential order, but may not be the real-time order. This also we observed A, B, it may happen A first or B first. That's what user may get 10 or 20. We don't know that. So the point here is when you write, suppose if you take one only, which operation is happened first? X10 happened. Which operation is happened next? X99 happened. Now, which can be replicated to other nodes? Maybe X10 can be replicated other nodes first, or X99 can be replicated other nodes first. If X99 is replicated other nodes, then X10 will be replicated later. User will get X equals to 10 only. So, this order of X10 right, X99 right may happen in any order, in any sequence, no guarantee for the real time. But one user operations, A is doing two operations, this has a guarantee. This is the slight change from the previous. If you understand the concept, scenario 1 is a combined in scenario 2 also, Anik. Scenario 1 is a combined in scenario 2. In scenario 1, you take as a X10 by A and B. Scenario 1, X equals to 10 and B you take if you want 99 only here. Okay, then it may return 10 or 99. So here the operations are maybe 10 or maybe 99. Now this is scenario 1. A is writing A is writing X10, B is writing X99. Which will happen first? These operations are different clients executed in some sequential order. So first A operation may happen, B operation may happen. Scenario 2, what I have taken? For A, added one more task. For A's both must go in a sequential order. Means for A, real time guaranteed. For B, it won't guarantee the A-B combination. Exactly, Sashi. It won't guarantee the real time order. Yes. So there is a chance to get a old data, stale data, wrong data, correct. This is not so strict as the strongest consistency model called linearizability. Now come back. So what is the rules to study? All nodes see the same global order of operations. All nodes will see the same global order of operations. Whatever happening in a one node, same happens in all. Preserve the client's program order of one client, each client program order operation. Does not guarantee the real-time order. Where this is suitable, multiplayer games, where shared data, collaborative editing, document editing, distributed counters or aggregation, distributed logging or auditing, and systems where order matters, but not a strict real-time order. Systems where order matters, some order is required, but necessarily not a real-time order, not a strict order. You tell me some other real-time use case scenario where I can do this. Some use case you think and tell me quickly where I can go for a sequential. Means I told you the use cases, but you tell me the scenario. I just explained to understand a concept. I take an X value, simply writing X, Y's. You take a real-time case, some real-time case. Don't use the points here. You use this. Google Docs means what it is. Means I want an explanation. Updated by one or more users. Okay. So what happens? Or you guys take this logging, you take distributed logging mechanism, you take and tell me. I think this is easy for you to explain. You take the distributed logging mechanism and tell me. Explain the use case. Abhishek, ticket booking systems, I think you need a strict, strongest consistency. You need online ticket booking, linearizability only you need. For online ticket booking, you need linearizability only. I have a central log, distributed logging is there. So this is writing logs, this is writing logs, this is writing logs. Okay. Now, did you get any clue? Suppose this is writing a log message, guys. Log MSG1. This is writing log MSG 101. Log MSG 201. Log MSG1. Message 1 it is. MSG1 number something. MSG1. MSG 101. Log message 201. So three different nodes are logging to distributed. Which one will be logged first? Which one will be logged first? Any real-time guarantee? Assume as per a time clock, suppose this is 7 hours, 25 minutes, 10 seconds happened. This log happened that time. This log happened 7 hours, 25 seconds, 25 minutes, 35 seconds. And this happened 7 hours, 25 minutes, 42 seconds. As per a time clock order, wall clock order, the first is this is written to the system. This is second written. This third written on the distributed system. The real-time order is MSG1 has to be logged. If you want to really log MSG1 only first, MSG101 as the next, MSG201 as the third, in the same real-time order you want to write, then you go for the first consistency model called linearizability. I don't want all that. But if you go to linearizability, availability, damages, right? You have to compromise in availability. Availability performance will come down if you go to the linearizability. So I don't want that much strict, but I want a little bit strict. So I'm coming for a sequential. Now, this user is writing log MSG1, MSG2, and log MSG3. Now tell me the order. Which one happens first? First, maybe you consider this is a node C, guys. Node C, node B, node A. So it may do like this also, right? Node A operation may happen first, then a node B, then a node C. Am I right? Or maybe BAC. We don't know. Some order will be maintained. But whatever it takes, these three will go in the same sequence. Understand that? Exactly, Swati. You're right. Naveen, you're right. This particular client's operations order is maintained. But all the clients order real time. If real time only maintains, then what is the difference between the linearizability and these guys? Linearizability, the small difference. Did you get that point? Linearizability, every operation real time guaranteed and immediate operations. If the same happening here also, it is doing always first A, then B, C, then the real time guarantee. Then it is a linearizability. So here, one client's operations order respected. A means M message 1, 2, 3 will be happening same order. But these three guys will happen in some order, not necessarily in the real time order. Is that clear? Is that clear, everybody, guys? Exactly. Preserve each client program order of operations. Each client, see the second point. All nodes see the same global order of operations. All nodes will see the same order of operations. Preserve client's program order of each client program operations, then does not guarantee the real-time order. So some use cases. So where you have to do homework is, after learning this, after going home, what you have to do is, you find a use case. Suppose I taken and explained to the distributed logging, right? Like that, you take some use case and draw a diagram. What is happening to understand more? So is this clear? Sequential, going to the third one, causal consistency. Causal consistency. Anek, can you explain the scenario in which even C reads 10 from N3 and 2 has 20 written, but you read 10 only? No, which one? Which one? Scenario 2 you are asking? Okay, scenario 1. Same here, come back here. A is writing x equals to 10. B is writing x equals to 99. Which one will happen, Anik, here? Anyone. That's the problem. Yes. It may write the x99 or it may write x10. So that's what the real-time order not guaranteed in this. The small line to understand. Or can I take the same scenario? Okay, in that style only means go to, yeah. This is your N1. This is your N2. This is your N3. Client A is writing x equals to 10. Client B is doing again a write operation, right? So here previous x is the 5, previous x is the 5, previous x is the 5. So whenever A is writing to node 1, B is writing to node 2, some update happens, some replication happens. Internally what is happening I am not showing to you. I am asking straight away question. Client C is doing the read X. Now what the C will get now? What C will get, guys? Yes. C may get 10 or may get 99. Now, if may 10, if C is getting means until, for example, I'm not telling you the whole flow. That's what you're not picking up that flow. See, for example, you consider that first two x10 given in the real-time order. This is the first, this is second. Okay. But assume this updation happened first. Then this is only replicated here first to 99 only replicated. This only replicated here 99 only. Now this guy is getting, C is getting 99 and maybe D also getting X value as 99. Now all has to, because this replication is completed, first is going, everyone has to see the same. Then later the second has to be replicated, right? X10 has to be replicated. Until the whole replication is completed for X10. X10 value replication is done across all the nodes. Until that, everybody has to see the 99 only. Even means intermediate it won't allow. So next you're going to update this 10 here, 10 here. Until that, it will take the same value. So only the key difference, Anik, only point you see here, the only difference you're seeing from the linearizability is, in the linear, if you apply linearizability, always a 10, x10 happens first immediately, then always x99 will happen. Every user will get 99 only, fixed. That is the linearizability. Strict order maintenance, real-time order maintenance. But in the sequential, anything can happen, no problem. Anything can happen, no problem. That is the what, Swati. Even see even the replication, suppose it is updated here, 10 is updated up to this. You see this now. This 10 replication happened here, guys. 10 replication happened here, guys. In this node 3 still not happened. Now anybody reading, X is reading here, somebody is reading here and reading here. X is 99, X is the 10 value. But the point is, that is the replication mechanism happens. Until the 10 is replicated to all other nodes, this will give you 99 only. This 10 is not replicated in the node 3. Until 10 is replicated in the node 3 also, it won't give this 10 here. This guy will get 99 only. Until the 10 replicated across all the replicas. That is the replica contract. That is the replica contract. That's the point. That's the yes. You got the point now. Until the X10 is replicated across all, every client will see the same. Right. So sequential is done. Okay, let's move to causal consistency. Exactly, Nitesh. Exactly. Our replication, I told similar replication architecture I explained in the databases. I told you replication, how the synchronous replication happening, acknowledgements coming to all of that, right? It has to wait until the final commit is done. It has to wait for all the replica acknowledgements. You see that until that they won't confirm the new copy. Right. So causal consistency. If one operation is causally affects another, then nodes, all nodes must see them in the same order. So one operation is causally related in other, then they have to see in the same order. Unrelated, non-causal operations or unrelated operations can be seen in any order. Okay. Now, related operations, the simple summary, guys, in the causal consistency, whether operation is given by anyone, forget about them. So it decides the causality, relation. If any two operations are related, then it maintains the order. No relation, any order it can execute. Just to relate to the previous, sequence is operations given by one client, it will maintain a sequence. Operations given by different clients can happen in any order. Am I right? Exactly same points put here, the small difference. Operations given by one client or any client immaterial to me. But any operations are interrelated, causally related, those will be maintained in the same order. If not causally related, no dependency, then can happen in any order. Okay, let's see the scenario. Suppose client A is writing the x equals to 1. Okay, we have considered as a 10 only, take as 10. Client A is writing x equals to 10, guys. Okay. Client B is reading. What client B will see? X equals 10 only. Simple over. Now client B is writing y equals to 20. Now is this write operation is depending on the A write or not? Because client B is reading x, then only writing y. So this write y is depending on write x? Yes. So this write y is causally depending on A's write. Now client C is writing z equals to 99. But this is independent, not related, not linked to either A or B. Now, what is the global operations it can see? First C operation also can happen, Z99 can happen, am I right? Then X10, Y20 must be in the sequence, or X10, Y20 ladder Z, or X10, Y20, Z and this. Others are, I hope you understand this. Tell me, guys, did you get this and the previous and this? Just small trick. Difference is there. Everything same only. Exactly. If suppose this is not there, then now tell me. A is writing x equals to 10. B is writing y equals to 20. C is writing z equals to 99. Any dependency between these operations? All are independent operations. Anything can happen now. Anything can happen. No real-time order. Any order, yes, any combination it can happen. No problem. But this is making the relationship. This is making the relationship. So, what right should happen always? A, B rights are casually related. A, B rights are casually related. So, A right should happen first. Then only B right should happen. And a C right can happen anywhere, no restrictions. But A, B's are casually related, so must happen in the same order issued by the clients. Clear, guys? Casual consistency is clear. Come to the key points. Casually related operations must be seen by all the clients in the same order. But operations that are not casually related can be seen in the different orders, no problem. Social media posts and replies, chat applications, collaborative workspaces, distributed caches, event-driven systems. These are all most you take one real-time example. Take the real-time example of social media posts, guys. Tell me one real-time example of casual consistency in social media posts. See, I am SRI. I am make the post. I make one post, guys. Making post. Okay. Make a post, something. Okay. Then who are there online? Ashwant is there. Ashwant also making one post. I am making the post. Ashwant also making the post. Now, do you want a real-time order for this? Do you want real-time order? Not required. Depending on availability of a servers, the clustering environment, let them 1 second my post may be going slowly. I only make a post. 1 minute back I posted. Maybe mine is going slow. Ashwant post is updated very fastly. Can happen, right? That is what I am telling. Anyone can be. Now I make the post. Okay. Now, for example, Anek is liked my post. Anek liked my post. And who are there on the screen? Abhishek commented my post. Now, these three you want to do in the same order or different order? First my post has to go. Then Anek and Abhishek will see my post. They have to see my post. After seeing my post, means they are reading the post, then making the comment or making the like. So the order must be, they cannot, first we cannot show the like of Anek, right? We cannot show the comment of, without my post visible, we can't show the comment and like of these two users. Because these are casually related. Yashwant post is not related to my post. Yashwant post can happen before to me also, no problem. No worry. Yashwant post can happen later to me, no worry. But my interrelated tasks are same order. So clear, guys? Causally related, simple. So sequential, causally related, there is a small line. Those are small difference. Based on the real-time scenario, how to use this? No. That's what I am telling. Girish, sequential. This is not given by me. Maybe I have written here wrongly. I'll make it more clear. See, Girish. So here there are multiple users. SRI, make post, Ashwant, make post. Then other user, Anek, like post. I'm giving a post number something. Post number 123. Anek is liking the same post number 123 given by the posted by the Srinivas only. And Girish also liking like post 123 given by this you tell me now. Tell me the order now. Tell me order. There are 4 different clients here, Girish. These are 4 different clients. Am I right? There are 4 different clients. Suppose, okay, my first question. These are 4 different clients doing 4 different operations, right? If you apply the sequential, then what is the order? Tell me. If you apply sequential, then what is the possible order? At least one order, tell me. Sequential, one order, tell me. Sequential, one order, tell me. Sequential, guys. I'm asking sequential. Second one. If you apply sequential for this use case, do you know what happens? First to Anek, then maybe Ashwant, then maybe Girish, and then maybe SRA. Is there any possibility, right, for this? Yes. First Anek like will be visible there. Then Ashwant post something, it is not related. Then Girish comment will be there. But my post is not ready as of now. Later my post will be visible. This is sequential. This is sequential. So different clients, operations, different client operations will happen in any order. No real-time order guaranteed. Any order can happen. Am I right? This is a distributed system. Maybe SRI is in India, Ashwant is in US, Anek in Dubai, Girish in UK. We don't know that. So anything can happen. But this is invalid use case, right? Without my post, how you want to show the like of Anek and comment of Girish, we should not show that, right? Now was the best case. This particular use case sequential will not fit. You have to go for casual. So in casual, what happens? Tell me. First, anything which happens. The point here is like by Anek is happening after the read. So first Anek is reading, then writing. So dependency. Girish is reading and commenting, writing. So depending on the post number 123. So first SRI must happen. Then after SRI, what happens? Tell me. First can be SRI or Ashwant, anything, we don't know. Okay, start with either 2 cases I am taking, A, B. Okay, first SRI or Ashwant. Next, after SRI, who can take this? After SRI, Ashwant also can happen, right? After Ashwant, SRI will happen. Okay. Or for some time, okay, for some time, keep the S1 aside. You take the remaining three cases, and here is one more trick. One more key point is there. And tell me this. Okay, first SRI, guys. Then tell me who is the next. One SRI. After that, who next? Anek or Girish? Anyone, right? Because there is no relation between these two. Anek and Girish, there is no relationship. The Anek operation, Girish operation are not casually related. So it can be Girish and Anek also, and Anek and Girish also. Now keep, this is the order fixed. This order is fixed, guys, because these are casually related. Now Yashwant will come either here or maybe the last, maybe in between also. The sequence should not be. Understand, guys? Now I think you got a clear difference between sequential and casual. Full clear, sequential and casual. Not each record, Anek, not each record. For each model, for each module, you can set it. Suppose if you are developing e-commerce application, okay, e-commerce application has so many modules, right? Product display, catalog module, order module, then stock management, payment gateway module. So for the different modules, you can apply different consistency models. Right? If it is feasible, still you can apply it. Yes, Anek, if it is really feasible, you can apply that. But generally, this particular use case, like comment, maybe comes under similar only, right? Casually related, depending on the post only, you have a comment and likes. Like, share, comment. These are the dependent, casually related on the post. So in this particular use case, definitely the casual is most suited. Exactly, Swati. That comments, that is actually a casually related scenario. Best scenario for casually related is social media posts, replies, comments. Each hierarchy is casually related. Exactly, right. Okay, guys. So that's it. Now we'll take a small break. Before the break, I'll give you one idea. You think on this. Suppose you have a Git, right? Git is there. Users are committing. Developer 1 is committing. Developer 2 is doing commits. Developer 3 is doing commits. So for this use case, which consistency model is the best for this? Tell consistency model. Consistency model. Which consistency model is best for the GitHub? Strict may not be required. Strict may not be required, guys. Suppose I am committing, Shashi also committing, both are committed. What is the big problem? If I pressed the commit button first, Shashi pressed next, but Shashi commit updated in the global first. Mine is updated last. What is the big deal? You get it? Think, okay, think. Anyway, you have a break. Take break and come back. After break, we'll continue this question and then we'll go to the next. Next. Okay, guys, let's take a break and come back.